Welcome back. In today's lesson, we're going to talk about the first form a linear function can take. And when I mean form, I mean a type of equation that a linear function can have. We talked about linear functions in the last lesson, slope, what the difference is between an equation, a graph, and a table with a linear function. And now we're going to talk about the first form that a linear function can take. And this is one you've probably heard of before. It's slope-intercept form. So after today's lesson, you should be able to write an equation in slope-intercept form from a graph, and you can graph a function given the equation in slope-intercept form. So you should be able to go back and forth between the two. So this form is called slope-intercept form, and it's called that because you can find the slope and find the y-intercept just by looking at it. So this is the form right here, y equals mx plus b. Should sound very familiar, y equals mx plus b. And y equals mx plus b tells us two things. It tells us the slope, which is m. In fact, I'm going to unhighlight that here. Instead, I'm going to highlight the m. So m, that's our slope. And the b, right here, represents our y-intercept. The x and the y we leave alone in this form. The x and the y, they just tell us that that's a coordinate pair on the line. So x comma y, let me get a different color, is a coordinate pair on the line itself. So each of those letters do stand for something on the line on the graph. So there are a lot of different ways that we can talk about slope and y-intercept. A lot of things are synonymous with slope and y-intercept. What I mean by that, if my slope is represented by the letter m, which it is, when we say m, we mean slope, we can call that slope our rate of change. We can call the slope the steepness of the line. We can say that it's y2 minus y1 over x2 minus x1. We can also say that it's rise over run. All of these things mean the same thing. They all mean slope, they all mean m, they all represent the same thing. It's just different ways we word it. Y-intercept is similar. Y-intercept we call b in the equation, but the y-intercept is more specifically where this line touches the y-axis on a grid. It's also your starting point when you graph. And it's also the coordinate pair when x equals 0. So we can define it in a lot of different ways, and I'm expecting that we know all of these different ways as we go through this whole unit together. Not just this lesson, but the whole unit will be coming back to this idea of slope and y-intercept. So we're going to start off simply. We're going to start off by, hey, can you write the slope-intercept form of an equation of the line given the slope and y-intercept? So for example 1, we're keeping in mind that we're looking at y equals mx plus b, where that m is your slope and that b is your y-intercept. So in this case, in letter A, my slope is 1/2 and my y-intercept is 0. So when I write my equation, I'm going to keep it in y equals mx plus b, but I'm going to keep the y, replace the m with 1/2, keep the x, replace b with 0. Now this is kind of a unique problem because 0 really means nothing. It means there's nothing there, nothing exists. So the better way to write this equation would just be y equals 1/2 x. Okay, notice that if I go back to my highlighters, I put 1/2 in front of the x and I put 0 at the end, but I kept the y and the x the same. Okay, example number 2, slope is 2. My y-intercept is 4, So when I write my equation, I'm going to have y equals 2x and then plus 4. Okay. Letter C, the slope is -3/5 and the y-intercept is -2. So that means that m, and I can write it in a different way, m equals -3/5, b equals -2. So then I've got y equals -3/5 x minus 2. Make sure you keep the signs. The signs have to stay the same. In the last example, D, my slope equals 1, so that means m equals 1. My y-intercept is -4, so that means b is -4. And in y equals mx plus b, that's going to look like y equals 1x minus 4. Now, in algebra, do we see this 1 in front of the x here? Right there. In algebra, we don't include those 1s in front of the x. We make those 1s invisible. So the best answer to this would just be y equals x minus 4. Now, something I want to be really clear about is that even though this formula, I'm going to go back up to the top, even though this formula has a plus here, that there, y equals mx plus b, that plus could also be a minus. It can be a minus b as well, like we've seen in a few of these examples, specifically C and D. It could be y equals mx minus b, and that's okay because the y-intercept could be negative, okay? There are special cases to what happens if the slope is either 0 or undefined. We talked about 0 and undefined slope earlier in the last lesson. So remembering that the slope of 0 in example E is going to be a line that is going to be horizontal like this. Now, if I have a slope of 0 and that's my m, so m equals 0, b equals 5, I'm going to have an equation that's y equals 0x plus 5. Well, if we look at that 0x, 0 times anything is 0. It goes away, and I'm just left with y equals 5. The x went away, and I just have y equals 5. Okay, that's going to be a horizontal line at 5 when y equals 5. So if I were to draw a picture of this up here, here's my coordinate grid. Here's 1, 2, 3, 4, and 5. Let me make that a little bit nicer here. 1, 2, 3, 4, 5. That means this line is going to look like this, going horizontally through the value 5. So that's what that line looks like. It's not the same as y equals mx plus b, but we need to be able to write equations for vertical and horizontal lines. So now let's go the opposite direction and take a look at what happens when my slope is undefined. Here, this is saying m is undefined, and it's going through this point 2, 4. Remembering that in a coordinate pair, x is 2 and y is 4. Now there's a really special thing to think about with this, and I'm going to draw a picture to show you. So let's draw a coordinate pair. Let's draw a coordinate grid here. Now this point 2, 4 exists here at over 2 up 4. So it exists right there at 2, 4. Now when slope is undefined, undefined slope has that scary up and down penguin, right? He's going straight down, it's undefined. And so if I were to draw that line in this graph, it would look like this. And what x value is that going through? It's going through the x value 2, so we call this equation x equals 2. This might be brand new, I'm not sure, but it's not the same as y equals mx plus b. It's a special case. When we have undefined slope, we always start with x equals, and you can look to the coordinate pair and just pick that x value of 2 in the coordinate pair. You don't have to draw the picture if you don't want to. Sometimes it really helps students though. Draw a picture, plot the point, and then draw a vertical line and see, oh yeah, that's x equals that x value of 2. So those are two special cases that don't necessarily follow the exact rules of y equals mx plus b, but they're graphs that will pop up throughout this whole unit. Okay. Let's switch gears. And what happens if you're given a graph and you have to come up with the equation? In the previous examples, I'll screw up. I gave you the slope, gave you the y-intercept, and you could write the equation. Well, what happens now if I give you a graph and I want you to write the equation? Well, we can find the slope and we can find the y-intercept ourselves if we're given the graph. So the first thing I want to do is find some points on these graphs. So I'm going to use red, and I'm looking for points, first of all, that is the y-intercept. So the y-intercept on this happens to be right here. It's that exact point where the line touches the y-axis. That y-intercept is at the value 2. So the y-intercept is at 0, 2. Okay, and my slope, I have to find a couple other points. I see the point here touches it exactly, and I see the point here touches it exactly, and the point here touches the grid exactly. So I've got 4 points to choose from, and it doesn't matter which point you pick. You're still going to now find, like you did in the previous lesson, rise over run. So I'm going to take my pencil and go up from any point, 1, 2, 3, 4. So the rise is 4, and my run is 1, 2, 3. And this is a positive line, it's increasing, so it's going to have not a negative in front. And so my equation is going to be y equals 4/3 x, because that is my m. The y-intercept, that's my b, and then plus. Okay, so my slope was 4/3, my y-intercept was 2, so my equation is y equals 4/3 x plus 2. Okay. Example B, same process. Let's look for that y-intercept first. So my y-intercept here is at -1, so 0, -1. My slope, I need to find a few other points along the line. So here's a point, here's a point, here's a point, here's a point. It doesn't matter which points you pick. They'll all have the exact same rise over run. So I'm going to go ahead and start at this point here and go up 1. And then it goes over 1, 2, 3. So my slope is 1/3, but this is a decreasing line, right? If I put my name on it, my name is going down. So I need to put a negative in front of that slope. Okay, so now my equation is y equals mx plus b. My m was -1/3 x, and then my y-intercept is -1. So y equals -1/3 x minus 1. I'll put a box on the other one too. Okay, so you should be able to find the y-intercept, find your rise over run, and then put the two together to make your y equals mx plus b slope-intercept form. Okay. I've got 2 special cases again. This is that horizontal and vertical line. So remembering that the slope of a horizontal line is going to be 0. My y-intercept in this case is 0, -2. Remembering that my equation of a horizontal line is always going to be y equals a number. And the number will happen to be that y-intercept, that y value there. So my equation is just y equals -2. Now my other example is a vertical line. That's always going to be x equals some number. And the number is whatever x value the line's going through. The slope is undefined. There is no y-intercept. But my equation with a vertical line always starts with x equals, and notice what is the value it's going through? It's going through the value of 3, so x equals 3. 2 special cases that, again, don't exactly follow that y equals mx plus b rule, but we still need to be able to write an equation for them. They still count as lines. They're still linear functions. Okay. And lastly, but not leastly, how do we graph a line given y equals m something in y equals mx plus b form? This is probably one of the most important things we're going to do, and that has to do with being able to plot points and make lines on graphs. Okay, so example A, y equals 2x minus 3. Let's first find our slope. So remembering that slope is that number in front of the x. So my slope is going to be 2, and I like to actually write this as 2/1. I like to turn that 2 into a fraction, so my slope is 2, And I can even rewrite it as 2 over 1 to help myself because we want to do rise over run. And my y-intercept is -3. Include the negative with that y-intercept. So when you go to write down what's the y-intercept, okay, that's 0, -3. You don't make a sign error. So I'm going to plot 0, -3. When I plot points, remember it's always x, comma, y. And when we plot a point, it's left and right. In fact, I'm going to make this a little nicer here, somewhere else. Okay, a point is always x, comma, y. And we always do the left and right first. Then the up and down. So if I've got 0, -3, I'm going to go 0 and down to -3 and make my point. And then my rise over run is I'm going to go up 2, 1, 2, over 1, make a dot. And I'm going to do this again over and over and over again until I fill the whole grid. So up 2, over 1, up 2, over 1, up 2, over 1. And I'm even actually going to go down 2, over 1. And the reason I went up 2 over 1 to the right is because notice what kind of line did I create? Did I create a positive line or a negative line? I created a positive line, which is what I want because notice there's no negative in front of the slope. That is a +2, so my line should be positive. If we look at the next example, so this is all I need for example 1 is you be able to graph that line. In the next example, my slope happens to be negative. Okay, it's a -1/4. So that means my line is going to need to go this direction. Make that nicer. It needs to go up and to the left. That's how I need to make my line, okay? A lot of us have been taught that if it's negative, you go up and to the left or down and to the right. And I don't necessarily like to teach you to memorize that. I like you to teach you you're going to form a negative line. So whichever way you go up, down, left, or right, make it so that you form a negative line, a decreasing line. So here's what I mean by that. The slope was -1/4. My y-intercept is at +2. So my y-intercept is at 0, 2. So I'm going to plot my y-intercept first at 2. And now I have -1/4, so I can either go down 1 over 4 or up 1 over 4. If I go up 1, I need to go left 4 because that's forming a decreasing line. If I go down 1, I need to go right 4 because that's forming a decreasing line. So it doesn't matter if you go up or down first, as long as when you do those directions, you make sure you form a negative line. I don't need you to write these on your paper. In fact, I'd prefer you not. I would rather it just look like this, a nice solid line. But I did that for you in the notes to show you how the rise over run works. So these would both be correct answers of graphing these two equations, y = mx + b. This can be a really challenging concept for students. I've seen it often, but graphing is something we need to get really good at this year because it's going to come up again and again and again. So please ask for help if you need it. If you didn't understand anything in this video, pause, come ask me for help in the middle of the video. I'm happy to answer any questions you have. Good luck on your practice.